February 2020, we were right about the e-learning day. So if it's 2021, this might not make sense. But right now I'm trying to record this video while my cats are both sleeping on the couch next to me because we have an e-learning day tomorrow. So we have discussed phase changes before. You've seen this picture before, this unit, where changes in state of matter, also known as phase changes, can be classified as endo or exothermic, depending on the movement of the energy for the substance to change. And so if we had a substance melt or boil, we would be adding energy to the system. It's increasing the energy, so that would be an endothermic system or endothermic change. So just note that anytime you go from a solid to a liquid or a liquid to a gas, those both would be endothermic changes. Exothermic changes would be when you're releasing energy, so when it freezes or condenses. So if you have a liquid turning into a solid or gas turning to a liquid, those would both be cases of exothermic reactions or system changes. It's important to note that the temperature of a pure substance remains constant during a phase change. So on this graph, now we'll see how this works. On this graph, this is just showing how the state of matter changes as heat is added to the right. Okay, and at point A, that's all solid. Okay, and as it travels, but then when it gets to B, do you notice how it flattens out? So that shows you that the temperature is not changing. That is the phase change from solid to liquid. So solid and liquid are both present at B as it changes course. But then once it's completely changed over to the liquid, then the temperature can increase until it gets to the boiling point. So C is only liquid present. But then D is another change situation where we are changing from liquid to gas. So both liquid and gas are, that's a cue. Both liquid and gases are present during D. And then once it gets all changed over to gas, then the gas's temperature can get higher. So this heating curve helps illustrate that to us, that the temperatures do not change during a phase change until all of the substance has turned over to the new form, and then when it's all in the new form, then they can get to a higher temperature. The energy absorbed during a phase change is equal to the energy released during a complementary phase change in the opposite direction. So, for example, when we have our enthalpies, which we're going to talk about in 6.6, the molar heat of condensation of a substance is equal to the negative of its molar heat of vaporization. So for water, the molar heat of vaporization is what this means right here. Okay, that's 40.7 kilojoules per mole. So the condensation is equal to the negative value of the vaporization. So that would be negative 40.7 kilojoules per mole. So you have the value, and that's the magnitude is the same, but you just have to think about, am I adding energy to make it move more, or am I releasing energy to make it move less, to help you figure that out. So in class we're going to do a lot more with this, but this was the information we could get to you before our e-learning day. So I hope you have a great day.